We've created a faceted reflector as our optical system and assigned a reflective coating using our Optical Properties Manager. We've also inserted an LED source. The next step in our Apex workflow is to trace rays. Under our Trace tab, we can see that we have options for choosing our trace settings, tracing a single ray, or performing a full ray trace. Under our ambient medium option, we can immerse our system under any media type that we choose. Under wavelength and power units, we can set a default wavelength for our system, as well as the power units that we want to choose for our rays. Under our Fresnel coefficient option, we can choose how we want to account for S&P polarization at any refractive interface. In ray warnings, we can choose to show any ray warnings that are generated during the trace, as well as terminate the trace if we receive too many warnings. In the Ray Termination tab, we can choose to terminate any rays that propagate in an undesirable direction. We can also set a maximum number of single object intersections, as well as a maximum number of total object intersections. And we can set absolute and relative flux thresholds below which our rays will be terminated during the trace. In our ray splitting and scattering options, we can choose the number of generations of child rays that will be generated at each splitting or scattering interface. In trace display, we can choose how many rays to show in the 3D model view once the ray trace is completed. And we can also choose to keep or not keep previously traced rays. Our Ray Arrows and Mist Rays option lets us decide how to display mist rays, the scaling of arrows attached to those rays, as well as the distance to extend those rays into our 3D view. And finally, we can choose to print ray statistics about our ray trace once it's completed. Now let's go ahead and do a ray trace, and we're now ready to perform analyses, which is the next step in our Apex workflow.